to the lesson for Chapter 3, Section 7. It's titled The Real Numbers. And what it's dealing with here is the real number system. And the real number system is broken into two parts. And so what we have here are rational numbers. And rational numbers are any number we can write as a fraction. So that's the big deal here, is any number that can be written as a fraction. And way back in the beginning of this book, we ended up dealing with just rational numbers, and we talked about that concept, and we talked about how rational numbers has the word ratio in there, and a ratio is a comparison of two numbers, and it is a fraction. Well, we also have these numbers called irrational numbers, and the prefix IR means not, so not rational. So these are numbers that we cannot write as a fraction. And so some examples would end up being like the square root of 2, or any square root that's not perfect. Another example would end up being pi. Pi is a ratio of the circumference and the diameter of a circle. However, it is an irrational number because the decimal does not repeat and it does not terminate. So that's the other concept here. So not rational, and the decimal does not repeat. So it does not repeat in a pattern or terminate. And so that's what we're looking at with irrational numbers. Then we have terminating decimals. So they break rational numbers into two different types of decimals. If you look at the decimal form, terminating are ones like this, 0.25. They just end right after the 5. It terminates. Where repeating decimals continue on, and we can write these as fractions, and we've done that in the past. From terminating decimals, we have non-integers. Non-integers would be like 0.25. But we also have some integers. Integers would be like numbers that are negative, like on the number line, -3, -2, -1. They could be smaller than that as well. We could also have 0 as an integer, and we also have 1, 2, and 3 as integers. And so those numbers can continue on as well. Well, negative integers obviously are the negative side, like the -3, -2, -1. But whole numbers include 0, so 0, 1, 2, and 3. Well, whole numbers can be broken into 0 itself, and then the natural numbers, which are counting numbers like 1, 2, and 3. And so what the first set of directions asks us is to write all names that apply to each of the numbers. So if you see a -1/4, what they're looking for is just, it is a real number, so we write down real, but it is also rational. And so we can write that down. So what the ones that we are looking at that we're going to end up using are these. We're going to end up using, and I'll go ahead and highlight those. So we're going to use real. You're going to either say it's rational or irrational. And then you're going to use integers, whole numbers, or natural numbers. Because 0 is included in the whole numbers. Negative integers are included in the integers. And then terminating decimals and repeating decimals are rational numbers. So you're going to use one of these, actually more than one. We've got to write all names. And so -1/4 is a real number. It's a rational number, but it is not an integer. It's not a whole number or natural number, so that's why I didn't include those parts. Well, if I look at 0.3, the square root of that, I can't take the perfect. It's not a perfect square. So since it's not a perfect square, that means it's not rational. But it is a real number, so we would say real and irrational. And we'll get to an example that is not real later on, but we've got to list all the different categories that apply to it, and those are the two that apply. Well, -25 is one in which we have more than the, move these over just a bit so I can have a little bit more space here. So -25 is one in which we have more than just a rational number. We actually have an integer as well. So let's write down all these parts so we know it's real because it is a rational number. And it is an integer because it's one of these, but it's not a whole number because it's negative. So we would say integer. Well, this next one, the square root of 400 over 4, what I want to do first is simplify it. So I see that if I went ahead and divided that, I'd get 25. Well, the square root of 25 is 5, so we've got to list all the different types of values that make 5. So the first thing I see is it's real, it's rational, but we also have that it's an integer. So it's an integer, and since it's positive, we have a whole number, but since it's non-zero, it's a number larger than 0, that means it's a natural number as well. So those are all the different categories that apply to that number. So we have another set of directions, so let's take a look at that. And it says state if the number is rational, irrational, or not a real number. So again, here are the different types that we have. We saw this chart before, and again, what we're looking at are the real number systems. So the real number system is broken into two categories. We've got the rational numbers, which are numbers that we can make into fractions. They're either repeating decimal or terminating decimal, and then we have the ones that are not fractions. Well, something that's not real, an example that we'll end up seeing would be a square root that has a negative number underneath the radical sign. So let me go ahead and fix that. So we would see something like this. If I had the square root of negative 16, this is not real. The reason is because there's no numbers that make this the case. So for instance, we know that 4 times 4 makes 16. I know that negative 4 times negative 4 makes 16. But I can't have two numbers that are the same that make negative 16. The only way to make negative 16 would be to have one number negative and the other number positive, but those are not the same value. And so these are not the same, so it has no square root. And so we would say this is an example of something that's not real. So let's go ahead and state what these are. So this number here, because the minus sign is on the outside, I could take the square root and then take its opposite. So this is called an irrational number. It's irrational because it's not a perfect square. Where this number is in the decimal form, so that means it's a rational number. This is the other example that is not that shows that it's an irrational number. Pi, there is an approximate for it, but we don't have an exact answer for it. So the decimal does not repeat in a pattern, and it does not terminate, so we call that an irrational number. Now here's the example of one that is not real. So numbers that are the square root of a negative is a term or a type of number that is not real. And 0 divided by 6, well, we can do this division. See, if I went ahead and off to the side did 6 into 0, 6 times 0 makes 0, and you see how I did the division. So the answer would be 0. So this answer is 0, so this is a rational number. It's rational because it's a whole number. So it's actually rational, it's an integer, it's a whole number, but it's not a natural number. Where this example is different though. You see this one, we have to divide 0 into 10. But 0 times any number is going to end up giving us 0. So it doesn't matter what number you put up there, you're never going to be able to complete the answer because then you'd have to plug in another number, and it could be any number. So we say this is called undefined. Undefined. So there's no definition of a number when we're dividing by 0. So this is a number that's not real. So those are the two instances that we'll have that are not real. Either a square root that is negative, that has a negative number underneath the radical sign. And we're not dealing with any other types of roots in this class, so we don't have to worry about those. And at least for not in this section. And then here we have 0 in the denominator, and that is not a real number either. So those are the examples on tonight's homework. Good luck.